Neuroscientists have recently released some exciting and significant news that will change our way of looking at the human brain. A new discovery has been made revealing that the human brain has structures and shapes that in turn can reach up to 11 dimensions. Scientists say they have found a world they would never have imagined. Through the use of algebraic topology, multidimensional geometric geometries and spaces were discovered in the neuronal networks of the human brain. Human brains are estimated to contain an average of 86 billion neurons, each cell having different connections that connect and expand in each direction, transmitting an incredibly large cellular network that allows us to think and reach conscience incredibly. What neuroscientists have discovered is the first geometric design of neural connections and how they react to different stimuli. To demonstrate how all human brain cells fit in order to perform extremely complex tasks, scientists have used visualization methods by creating virtual models through computer software. In their study, scientists reveal how structures are formed at the same time they are interlaced in a unit that creates a precise geometric structure. A neuroscientist who is director of the Blue Brain Project in Lausanne, Switzerland, was interviewed and said, "We found a world we never imagined before. We have discovered tens of millions of these objects even in a small portion of the brain, up to 7 dimensions. However, in some networks, we have also discovered structures with a maximum of 11 dimensions. All neurons within our brain are enabled to interact with other adjacent ones in a precise way, to form an object with intricate connections. Surprisingly, neurons more adhering together in larger groups or families are included in the object." Neuroscience experts have actually performed a test on a real brain tissue to make the correct results. In an interview with Wired, Ran Levi Aberdeen, a mathematical scientist from Aberdeen University, said, "The presence of large cavities when the brain is processing information indicates that the neurons in the network respond to stimuli in an extraordinarily organized way. It is as if the brain responded to a pulse and then built a multidimensional block tower, smashing. Formidable, starting from bars, 1D, plates, 2D, cubes, 3D, and then more complex geometries with 4D, 5D, etc. The activity sequence across the brain resembles a multicolored sand castle that has the ability to materialize out of the sand and then disintegrate." Professor Cees van Leeuwen of Leuven, Belgium, said in an interview with Wired, "Outside physics, large-size spaces are commonly used to represent complex data structures or system conditions. For example, the state of a dynamic system in state space. Space is merely the combination of all the degrees of freedom the system has, and its state represents the values that these degrees of freedom are taking." The evidence of this research was published in the Frontiers Scientific Journal in Computational Neuroscience.